Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya. So guys, in last session of aircraft performance subject, that chapter was atmosphere, right? So we had seen the derivation in atmosphere chapter, that was troposphere and stratosphere derivation. So today we have to solve few numericals based on the troposphere and stratosphere. All right. So first I will mention here. Check. This is troposphere, and here we have stratosphere. Before going to solve numerical, we have to recall the formula. Okay, so first was the temperature. Troposphere start from 0 kilometer and ended to 11 kilometers. Similarly, this is 11 to 50 kilometer. All right. So temperature at any altitude TH is equal to T naught minus LH. Second, pressure at any altitude pH is equal to P naught pH by P naught to whole power 5.25. And what was the density variation? Rho h by rho naught pH by P naught to whole power 4.25. And fourth, lapse rate, that is L, which is nothing but temperature variation with respect to altitude dH is equal to 0.0065 Kelvin per meter or 6.5 Kelvin per meter. Similarly, in stratosphere, what is the temperature? So I told that day in last session that temperature in stratosphere will be constant, and what will be the temperature? It is exactly at 11 kilometer where troposphere ended. Same temperature you will have in stratosphere throughout the stratosphere, 56.5 degrees Celsius something. Accurately we'll calculate that. Then we'll calculate pressure. So pressure at any altitude pH, because the reference line now it will be 11 kilometer for the stratosphere. So it will be G upon R at 11 kilometer, RT at 11 kilometer, 11,000 meter minus H. Similarly, density that will be same rho H by rho 11 kilometer is equal to same as pH by P naught, P11. Okay, so this is the formula. No? R T at 11 kilo. We'll solve problems. It will be very clear. Don't worry. Okay, this is the density. And what about lapse rate? Because it is the stratosphere where temperature is what constant, so derivative dt by dh will be 0. It means lapse rate in stratosphere will be 0. So here it is like the formula, this all the formula here it was derived in last session. If you watch last session video, so you definitely will get the derivation. But again, I will tell you, like in gate and all, you need to remember the formula. That is more than enough. Derivation, every time you don't go for the derivation and all, even in examination you have to remember the formula and directly use the formula in an examination, because you will not have much more time, okay, in exam to derive the formula. And also better you just mark up the formula, that's all. Guys, now we'll solve the problems. So this is the problem number 1. Okay, find temperature, pressure and density at 4 km altitude from sea level. Okay, now at what altitude you have to calculate the pressure, temperature and density? It is at 4 km from sea level. So just say this is earth, okay, somewhere here, and this is what sea level. Must say this is the sea level. This is what exactly 4 km altitude from sea level. I must mention this is what sea level. All right, sea level quantity, you know, temperature T naught, it is uh, the sea level value. Pressure P naught, it is the sea level value, and rho naught, it is the sea level value. Okay. T naught is the sea level temperature, which I have given the data last class. It was a ISA International Standard Atmosphere value 15 degrees Celsius. If you calculate in Kelvin, so 273. So you just add 273, it will be 288. What will be the pressure? 101.325 Newton per meter square. What is the density? 1.225 kg per. So these data, it is nothing but sea level value, and it is constant. Okay. What you have to find? You need to find pressure. What is the H? 4 km pressure you have to calculate. Temperature at what altitude? 4 km, and density you need to calculate at 4 km. So basically, what is the H here? They have mentioned 4 km. This is the H. I hope you understood now. Okay. So first we'll calculate temperature. How to calculate? What was the formula at any altitude TH? Formula was T naught minus LS. This formula I had derived in last session. So TH means what? T at 4 km. What is T naught? It is sea level temperature 288 minus L. What is the L? L is the lapse rate. What is the value? 0 in troposphere, 0.065. If this question is what they have asked, 4 km altitude, so this is what troposphere. Yes or no? First troposphere range is what? Till 11 km. So here remember this. This is what troposphere. Okay. So you will use the troposphere formula. This is the troposphere temperature variation formula. L is 0.0065 into H is 4 km. It means 4,000 meters. Okay, 0.0065 into 1000, 4,000 to 88 minus this is 262 Kelvin. Okay, this value is 262 Kelvin. This is the temperature. What is the pressure? What is the formula? Ph by T naught is equal to Ph by T naught to whole power 5.25. What is H? H is 4 kilometers. So you want to calculate 4 kilometer pressure at 4 kilometers. It is T naught into TH. What is TH? Temperature at 4 kilometer divided by T naught. What is the T naught? 288 to whole power 5.25. If you write this value, what is the P naught sea level value? 101325 into what is the temperature at 4 kilometer? Just now you have calculated 262 divided by 288. If you calculate this, then what value you may get? Let me check. 262 divided by 288 to whole power 5.25 into 101325. 101325. It is 61 61 657.77 Newton per meter square. Okay, or you can call this is nothing but 61.65 kilopascal. This is also correct. Now we'll go for density. How to calculate density? Rho h by rho naught is equal to what is that? Ph by T naught to whole power 4.25. What is the h? H is 4 kilometer. That is rho naught into what is h? 4 kilometer divided by T naught to whole power 4.2. I will keep the value. What is the sea level density? 1.22. What is 4 kilometer temperature? Just now it is you have calculated. It is 262 divided by 288. If you calculate 262 divided by 288 to whole power 4.25, 0816. So this is the density. All right. So hope you understood like how to calculate pressure, temperature, density in troposphere. We'll try one more numerical in troposphere. Yes. Problem problem number 2. Any altitude you can take. Right. Find temperature, pressure, and density. Okay. Density at 11 kilometer altitude. Okay. From sea level. From sea level. All right. Now, so check. So again, I will show you what is the mean of it. Simple. This is what sea level. Okay, Earth. Huh? Why I'm talking about sea level? Because they have given from sea level. So sea level, and at what altitude? It is mentioned 11 kilometer. What is this 11 kilometer? I told you this is the outer edge of the troposphere. Means still you are in troposphere. So H is nothing but 11 kilometers. Yes or no? What is H? 11 kilometer, which means you are in troposphere. Beyond 11 kilometer, if you go, then stratosphere will be started. Okay. So in troposphere, you know data. What is the lapse rate in troposphere? It is 0.0065 Kelvin per meter. Sorry, Kelvin per meter. Okay. Or can write 6.5 Kelvin per kilometer. What is the sea level value? I mean temperature, sea level temperature, sea level temperature. It is nothing but 288 Kelvin. What is the pressure at sea level? It is 101,325 Newton per meter square. Yes or no? Similarly, what is the density? Not value means sea level. Okay. What is the density? 1.22 kg per meter cube. Then this is the pre-assumed data, because this is the sea level value, and you have assumed that through the experiment and all you have calculated it. So in ESA it is given. Okay, so that you have to remember, because it is not going to change. For the troposphere, 0.0065 Kelvin per meter, that is lapse rate, and similarly temperature, pressure and density for the sea level, it is not going to change. Now we'll go for the calculation. What calculation you are going to do first? Temperature. Okay. What is the temperature formula? Temperature formula is at any altitude, it is Th is equal to T naught minus LH. What is H? 11 kilometers, so I must write sea level temperature 288 minus lapse rate. What is the height? It is 11 kilometer, convert into meter, 11,000. Okay, we just calculate it. It is nothing but 0.0065 11,000 288 minus this. I'm getting 216.5 Kelvin. This is the temperature at 11 kilometers. We'll go for the pressure. What is the formula? pH by T naught, pH by T naught to whole power 5.25. Okay. So what is pH? It is 11 kilometer into T naught, T 11 kilometer divided by T naught to whole power 5.25. So what is P11? 101,325 216.5 divided by 288.5. If you calculate this, how much you may get? Wait, This is nothing but whole power 5.25 multiplied by 101,325. I'm getting 2264 9.5 Newton per meter square, or I can write 11 kilometer is equal to how much? 22.649 kPa. Okay, this is the pressure at 11 kilometer. Similarly, I can calculate density. Yes, what is the formula for density? Rho h by rho naught, T h by T naught to whole power 4.25. What is rho h? It is 11 kilometer. Rho naught into what is T h? H is 11 kilometer divided by T naught to whole power 4.25. We'll keep the value. What is 11 kilometer temperature? 216.5 divided by 288 to whole power 4.5. We'll calculate this. 216.5 divided by 288 whole power 4.25 multiplied 1.22 multiplied by, you just wait, 216.5 divided by 288 to whole power 4.25. Okay, now multiplied by 1.22, I'm getting 0.362 kg per meter. This is the value. All right, so one very important point, troposphere. Okay, it is from sea level to 11 kilometers. Yes or no? Now, see, this is Earth. So, Earth, this is sea level. So, sea level, and this is what? 11 kilometer. Okay, this is what? Sea level, and this is what you just say 50 kilometers. So, from 0 to 11 kilometer, this is what? Troposphere. Listen carefully. And from 11 kilometer to 50 kilometer, it is stratosphere. Yes or no? At sea level, what are the data? T naught, T naught, rho naught. All right. At 11 kilometer, what are the data? T 11 kilometer, P 11 kilometer, rho 11 kilometer. These are the data at 11 kilometer. Anywhere, okay. So two station I have shown you. So in troposphere, two station data it is given at sea level and exit of the troposphere, that is at 11 kilometers. Okay, P naught, T naught, rho naught. Why I am writing this? Because it is very important to tell you like how to proceed numerical for stratosphere. So for that reason, troposphere, that two data you need to remember. Okay. At 11 kilometer, what are the data? It is T11, P11, and similarly rho 11. Just now we have seen that. So you remember 11 kilometer density 0.36. T11, what is the density? What is the pressure at 11 kilometer? 22.649. kPa. At 11 kilometer, what was the temperature? Remember 216 point. Okay. So now for the troposphere starting and ending data you should know. Okay. I mean sea level it is universal value, so that you always remember. And at 11 kilometer, that is the outer most of the troposphere, which is nothing but T11, that is 216.5 Kelvin. Then again pressure, density. Okay. Now my next question will be calculation of pressure, temperature, and density in stratosphere. So let us see. Problem. Fine. Temperature, comma, pressure, and density at 14 kilometer from sea level. Okay. Listen. So in this case, again I will show the diagram. Same. This is what Earth. This is what sea level. They are asking question at what altitude? 14 kilometer. So sea level means initial point will be the sea level. That means 0 kilometer, and data you have calculated at 14 kilometer. So from sea level to 14 kilometer, you know that partition will come. I mean, directly you cannot go for the calculation at 14 kilometer because you don't have any formula. Two zone you have troposphere and stratosphere. So for troposphere zone you have separate formula. For stratosphere you have separate a formula. So this 14 kilometer is the stratosphere. Yes or no? Because more than 11 kilometer will come in to stratosphere zone. So now from sea level to stratosphere, now again you are not able to use the formula. Why? Because from sea level to stratosphere, troposphere zone will come up to what distance? At 11 kilometer. So it is very clear now from sea level to 14 kilometer that formula will not be same. Why? Because two zones are coming separately, troposphere and stratosphere. So in troposphere zone only troposphere formula will work, and in stratosphere only stratosphere formula will work. There is no formula that which can work for both troposphere and stratosphere. I mean directly you cannot calculate any data from sea level to at 14 kilometer. So what you will do, first you will calculate data in troposphere from sea level to 11 kilometer, and once you know data at 11 kilometer altitude, then again you can apply stratosphere formula from 11 kilometer to 14 kilometer. I hope you understood now. So at sea level, what are the data? P naught, P naught, rho naught, you know that. At troposphere 11 kilometer, what are the data? P 11 kilometer, okay. Pressure at 11 kilometer and density at 11 kilometer. What are the data? T 11 kilometer is 216.5 Kelvin. Huh? P11 is nothing but just now I have written the data. P11 22.649 kPa. And what was the density at 11 kilometer? Check 0.36. So in exam, better if you remember the data at 11 kilometer, directly you can use this. Otherwise, they will ask the value in stratosphere, but if you don't know data at 11 kilometers, so you have to use troposphere formula and you have to calculate all the data like T11 kilometer, P11 kilometer and rho 11 kilometer. Then you will go for the calculation for the 14 kilometer. But if you remember the formula at 11 kilometer, what are the temperature, pressure and density values, then directly you use stratosphere formula. Like now you just see, you will understand what is the H. It is 14 kilometer. This is what is stratosphere. So in stratosphere, first calculation will go for calculation temperature first. What is the TH? TH is nothing but T 14 kilometer. I told you in stratosphere temperature must be constant. Here temperature must be constant. And what will be temperature? The temperature at 11 kilometer, because stratosphere starts from 11 kilometer altitude. So what will be the temperature at 14 kilometer? It will be the same at 11 kilometer. What is the 11 kilometer temperature? It is 216.5 Kelvin. Understood? Yes or no? Now we'll go for the pressure. Pressure formula is pH by in stratosphere. Okay, in stratosphere I'm saying pH by P11, because what is the reference point for the stratosphere? It is 11 kilometer altitude. E to power G by RTS. RTS S means stratosphere, that is 11 kilometer. Okay, because what is the stratosphere temperature throughout? It is exactly 11 kilometer temperature. 11,000 minus H. So what is the pH? pH is the 14 kilometer is equal to P11 kilometer value into E to power G by RTS. S is nothing but 11 kilometer temperature. 11,000 minus H. What is the H? H is nothing but 14 kilometer. So 14,000 meter. Now we'll keep all the data. What is the P11 kilometer? It is, check. It is nothing but 22.649 kPa. 22.649 kPa. kPa kilopascal means 10 to the power 3 into E. G is nothing but 9.8. R is nothing but that value, universal gas constant. I have given that universal gas constant value in once I have told you that sea level data. So there I had mentioned that R value. Yes or no? So the same value you have to use here, because see, they are saying air, they are not going to change the gaseous characteristics. So whatever the characteristics gas constant value, that value will be same for troposphere as well as stratosphere. Okay, and that is nothing but 287. Okay, into what is the T11? It is 216.5. 11 kilometer minus 14 kilometer. Keep in meter depth. Let's calculate this. How much will you get? Right. It is 11 kilometer minus 14 kilometer. Okay, into 9 point divide by R, 287 divide by 216.5. Okay, And what is the value of exponent? I have to write the power. Wait. Okay. So if you check this data, you will get 11,000 meter minus 14,000 into 9.8 divide by 287 divide by 216.5. Okay, to whole power this exponent 0.62. This is nothing but what, 22.649 10 to the power 3 Pascal. Into this data you will calculate, you may get 0.623. If you do that, calculate by 22.649. You will have 14.111 10 to the power 3, or you can say it is 14 kPa or 14.1 kPa. That's all. Similarly, density, if you calculate, what is that density? Rho h by rho 11 kilometer. It is nothing but e to power g by r t 11 kilometer. 11 kilometer minus 14 kilometer. This is the value. No? So density at 14 kilometer will be density at 11 kilometer e to power g 9.8 divided by r 287 216.5 in bracket 11 minus, you had seen this 11 kilometer density you had seen here. What is that? 0.362. So it is 0.362. This data you have calculated just previous for the pressure, that must be same. What is that? It is 0.623. Point, calculate 0.62. If you do that, 0.362 into 0.623. Right. This is nothing but 0.225 kg per meter. These are the calculation for the pressure, temperature, and density in stratosphere. Again, you can go for 15 kilometers, 16 kilometers, 17 kilometers. So this will be the process. I mean, you should know pressure, temperature, and density at 11 kilometer. That will be the reference point for the stratosphere. Okay. And again, if you want to calculate anywhere, I mean 20 kilometer, 19 kilometer, 25 kilometer, anywhere in the stratosphere, if you want to calculate, very important, you should know data at 11 kilometer, because that will be the reference point for the stratosphere. All right, I hope you all understand. And any problem, if you may get, you can drop message in comment box, so I will tell the solution. But here, whatever I have told you, if you apply, then I'm sure like there will not be any problem in calculation in troposphere as well as stratosphere. Okay, guys. So keep doing hard work. Thank you. Thank you all.